This is ACM ByteCast, a podcast series from the Association for Computing Machinery, the world's largest educational and scientific computing society. We talk to researchers, practitioners, and innovators who are at the intersection of computing research and practice. They share their experiences, the lessons they've learned, and their own visions for the future of computing. I am your host, Rashmi Mohan. If you have ever sat in a hospital urgent care room agonizing over when your turn with the doctor will come, you have surely thought of many creative ways to solve that problem. Well, fret not. Artificial intelligence solutions today are analyzing waiting room data to streamline patient movement and optimize for the least wait time. And that's just the tip of the iceberg when it comes to the applications of AI, ML in healthcare. Our next guest is at that perfect confluence of these exciting fields. Eugenio Zuccarelli is a data science leader with the Fortune 5 company CVS Health. He has worked across multiple industries, has been featured in many leading forums and publications for his exceptional contributions, including being listed in the Forbes 30 Under 30 list and being a TEDx speaker. He has studied in premier institutions across the world, including MIT, Harvard, Imperial College London, and the University of Genoa. Eugenio, welcome to ACM ByteCast.
Thank you for having me. It's a pleasure to be here.
Wonderful. So I'd love to lead with our question that I ask all my guests, Eugenio, which is if you could please introduce yourself and talk about what you currently do, as well as what drew you into the field of computer science.
Definitely. So I'm a data scientist. Right now, I'm more on the management side, so leading a team of data scientists, but I definitely come from the data science spectrum. And as you said, I've been studying it across MIT, Harvard, Imperial College, and the University of Genoa. So a lot of training on the technical side, and also quite a bit of an experience on a few different industries, from healthcare to automotive to fintech. And so I have basically started my career working in data science from the technicalities, writing Python code, writing machine learning models, and I still do that too, but I'm now leaning more towards how can we better develop a team of data scientists and how can we do this at scale.
Wonderful. That sounds very exciting. And I love the diversity of the work that you've done. What drew the interest into computer science, Eugenio? Did that start early on while you were in school?
Yeah, I've always been passionate about engineering and robotics and all of these technologies. I'd say my family, we've always been pretty passionate about engineering, maybe on a few different areas of engineering, like civil engineering, but we've always been very technical. And so I've always had this passion on the technological aspects. And I started working when I was younger on side projects. I felt this fascination with robotics especially. And so I started studying electronic and software engineering in college. And from then, I've been moving a bit more towards the software side, but that's pretty much where it started.
That sounds great. Was there a certain teacher or a certain project that really led you towards sort of machine learning and AI? Or was that just by chance?
I would say it mostly started when studying in college, specifically electronic and software engineering. I felt a bit of a sense of, something missing. It was amazing technology that we built, but it was a bit more for ourselves, so to say. We've always been really passionate. We were really passionate about technology, but it was missing some component, which I quickly realized was the human component. So doing something for a specific purpose, and especially something that could help people. And so I started working a lot at the intersection of neurosciences and artificial intelligence, electronic and software engineering, and that led then to this fascination and passion with AI and data science.
Doing a little bit of research on your background, that came across pretty strongly, Eugenio. I think the idea that you speak of, the human connect and understanding how technology can sort of benefit or help us understand humanity better. I was reading a little bit about your project Us, and I was wondering if you could tell us more about it. It sounded really intriguing, but I would love for our audience to hear more from you.
Yeah, Project Us was one of those project, and it still is one of those projects that is a great way to showcase both for us, technologists, and for the users, how we can use technology and engineering to actually do something for the people and not for the technology itself. And Project Us started as a way to try and understand empathy. So it's a concept not very specifically tied to healthcare sometimes. It's a bit more on the space of maybe mental health, which sometimes is left a bit out of the healthcare conversation. But it started as a way to try and understand through artificial intelligence if we can understand empathy, if we can foster empathy, so we can make people be better in tune, more in tune with other people. And it started as basically a tool that people wore as a bracelet. And the question was, can we infer the emotions, can we infer the empathy from the signals that we perceive from these bracelets and use AI to do all of the computation? And then COVID happened, and so we moved much more from the physical components of a bracelet to online interactions, to Zoom. And so it became a bit more about how can we use AI and data science to understand emotions through online conversations, through Zoom calls, and how can we align these emotions from the two participants so that we can make them more empathetic, so more aligned with each other, but also they can understand each other better. And this is extremely important when you're talking to your boss and maybe there are some miscommunications, or if you're talking with people from across the world. And so there might be also cultural components there.
That sounds really fascinating. What exactly are you measuring? So whether it is the wearable device that you were speaking about, which is the bracelet, or for example, even if you're looking at, I'm guessing maybe text from online conversations, like transcripts from online conversations to understand emotions, and then I don't know, do you give an empathy score? Do you give guidance to somebody? How does this work?
It's a great question. So it's a multimodal system. So it takes in a lot of different inputs. One is the images, of the faces of the people, exactly as we see them on Zoom. And so there is a lot of image recognition on the faces, on the emotions, to try and infer the emotions from the image themselves. But we also extract a lot of the text from the conversation. And so sort of NLP input together with also the signals from the voice. And a lot of as we all know, a lot of the communication is not just about the words. It's a lot about the facial expressions and also about how we say things, like the intonation. And so with all of these data points, we've been trying to build a single model that tries to approximate, so to say, a person, at least in the communication aspects, to try and then put a sort of score, as you said, on the emotion and on the balance of the conversation. So if it's positive or negative. Now, obviously, the idea is to try and do everything perfectly, trying to understand all of the different emotions, all of the different types of interactions, so to say. But we've started with something simple, so positive or negative emotional interaction.
Wow, yeah, no, that's phenomenal. I mean, did you ever think about how this would eventually? I mean, I understand it was research, and to be able to get to even that level of analysis to say, is that conversation positive or negative is phenomenal. Did you ever think about how this might make its way into being like productized?
Yeah, definitely. And right now, there is a specific team working on this project and also carrying it forward from research to something a bit more on the product spectrum. But there are countless of possible applications. You can think of the HR type of applications. So we can create better training tools where it's not just about the communication, the text, the words, but it's also about the emotions and the empathy components of interaction. So that's fascinating, at least to me, because it's a new way to understand training and HR systems, but also take into account the human component, the cultural component. And you can also think about other possible product applications in vehicles while people are driving. You can try and understand the current state of emotion of a person driving a vehicle or even just having any other type of interaction with a device. That can be a car or can be any other tool. But it's pretty challenging and also could lead to some negative outcomes. And so it's one of those situations where obviously you would like to better understand the emotional status of a person so that you can take care of that in case anything happens. Yeah, definitely countless of possible applications.
For sure, yeah, no, and I'm so excited to hear that there is continued work that's happening along this. I mean, I'd love to see what eventually comes out of it. I mean, I'm guessing there's a lot of this data that's already making its way into product, but yeah, no, I'm very excited to hear that there is continued work around it. But yeah, I know that for you personally as well, you've worked in so many different domains. You were speaking earlier, you're talking about working in the automotive domain, working in fintech. What was that common thread that sort of you learned through all of those various domains? Like what led you to each of those? Those are pretty, I mean, it's one thing to talk about, AI and ML research, which is what your expertise is in data science, but also understanding applications of that in different domains. Did you find the common thread across those?
Yeah, definitely. And I would say one of the common threads, as you said, is obviously the technology. Like AI and data science is a fantastic tool because it's applicable to basically every industry, every sector. Regardless of a company, regardless of the application, you will always have data, and all of these methodologies and approaches are very scalable and they're applicable to basically any possible application for an industry or for a company. But I would say probably the common thread I've found is the initial thought that maybe some industries might be less sort of risky or sort of less challenging in terms of applying and implementing an AI system. And so some might say, that the healthcare industry, for instance, the healthcare sector might be an area which is extremely challenging in terms of applying AI systems because it's so high risk in terms of applications. You're working with people's lives. But I've got to be honest, working in all of these different industries, you realize very quickly how basically, especially now, every sector, every company really deals with very challenging situations. So there is no single industry where now you can say, well, applying an AI system is easier than in another industry. And for a lot of reasons, every company has sensitive information, has a lot of data, and has a huge responsibility in terms of their users. And so while at the beginning it might seem that some industries might have been easier in terms of implementation, easier in terms of regulatory components or bias or ethics, it's actually not the case. Every single industry has a lot of challenges, and we really have to be careful in how we use these technologies to do the right thing and also take into account the human component all the time.
I think that's a very, very important aspect that you just brought out, Eugenio, because you're right. When you think about AI in healthcare and people's lives, that tends to be, we automatically tend to take that a lot more seriously and a lot more cautiously. I think there's a lot more probably apprehension in terms of saying, I don't know if I can really use it for something that important. However, when you talk about, especially when you're talking about driverless vehicle navigation, etc., those have some very significant safety considerations. When you're talking about fintech, I mean, there's people's financial health. And I think one thing across the board is around, data privacy, right? I don't want my financial data to be exposed any more than I want my health data to be exposed.
That's totally right. And, back in the days, probably 10 years ago, when social media and all of these other industries might have not been at the point that they are now, some of the conversations were, well, the healthcare industry is an extremely challenging one, as you said, because it deals with people's life and death. Something else might be, for instance, the social media industry might be less challenging, might be easier to implement a system and not have to go through regulatory approvals or not having to focus on explainable AI. But now we can see that, obviously social media is one of those areas that has to be really understood. All of those models have a huge impact on people, on the younger generations, on elections and so on. And so there is really no single industry now that's exempt to, interesting and challenging conversations on bias, ethics, and so on.
Yeah, and I think the thing that you had brought up earlier as well around AI in mental health, right? Also, an often ignored. Maybe there's more sort of attention now, but we in general tend to think of surgery or decisions being made in the hospital rooms versus things like using AI to think about better mental health care, right? Whether it is talk therapy or medication management, etc. That's also a significant area where I think there could be tremendous impact. One of the things that you spoke about in your TEDx talk as well, Eugenio, was around the prohibitive cost of healthcare in developing nations and also in developed nations. And one of the things you specifically mentioned is around the fact that sharing of data in healthcare is not easy. Does that come from, I mean, when I say sharing of data, I don't mean between like two organizations, but even just between like a provider and a patient, or between two different disparate systems that a single hospital is using. I would love for you to sort of expound on that a little bit more. Since the talk that you gave, do you think that we are making strides in the right direction?
We definitely are, but still, it's one of the greatest challenges of the healthcare industry. It's what's usually called the interoperability issue. So systems that do not really talk to each other, they should talk to each other, but they do not really do so. And as you said, even within the same hospital or organization, across different maybe specialties in medicine of same hospital, you still have systems that don't talk to each other, and so this creates a lot of issues on the patient. And I'll say this probably started because there is no patient-centric, person-centric approach in terms of data sharing, or at least there's not been up until now. And this is true for every single country, developing or developed country, really have a big issue in terms of sharing data. And obviously for a person like me that has lived in a few different countries, that's an even worse situation. But even for people just that have been moving across cities, in the US or in any other country, they still face this issue where the records that are about their health, they obviously should always be the same. Health is still the same. The history of their diagnosis, procedures, and so on still stays the same. But it's not really the case in terms of data. And so this creates a lot of issues, obviously clear issues on the AI machine learning side. Models are not able to better understand what's the real situation of a person, and so they might create predictions or to take decisions on missing information. But at the same time, also patients themselves, if they do not really have the information available, they cannot share it with doctors in an easy way. And so that creates a lot of issues in terms of diagnosing and using the whole available information to actually do the diagnosis and take the right decisions. And so sharing data is not just about administrative tasks or reimbursements or insurance claims. It's more about having a complete picture of the patient so that all of the parties involved, like the doctors, the nurses, and so on, can really take and make the best decisions for the patient with all of the information available.
Got it. Yeah, no, I understand that. But I wonder, Eugenio, especially when it comes to patients, and if they're not that sort of maybe familiar with, what data is being captured about them or how to share this data, I'm wondering how much of this problem is that in that there is no simple way to capture the data. Forget about sharing it.
Yeah, I'd say that's definitely a good point. But to some extent, it's also a matter of, how we can create better processes for this. Because you're definitely right in saying the data collection process is challenging. We've got still a lot of doctors across the world that capture this information on paper. And so that's definitely a big issue. And so sharing comes after, and acquiring data and understanding the importance of it comes first. And I'd say that's also sometimes one of the sort of cultural issues with doctors having to prioritize the care of a patient versus acquiring data correctly. And so obviously that's the right decision. You want a doctor to focus firstly on the patient and their health. But at the same time, you also want to create a system that allows the patient to do that while capturing information correctly. And ideally, that's going to then lead to better decision making, better systems, more data sharing, and also more artificial intelligence that can help with the whole decision making process.
Yeah, no, I mean there's just so much scope for better solutions to be built in that space. I think it's a great area for anybody who wants to explore that. How much of this problem, Eugenio, is a trust issue? I know that I can share the data and I know how to, but I'm not comfortable with it because I don't know what is going to be done with it.
That's right. I would say trust is probably the key word in here. And everything revolves around trust. You have data sharing, which is a matter of trusting the different parties, trusting who you're sharing the data with, but also the whole process in between. And I was actually speaking at a panel on privacy enhancing technologies. So on technologies that can help doctors and hospitals share data better. And one of the key insights there was that we can have the best technologies to share data, to do all of these processes. But if we don't have a trust, and there is not trust built between parties, across the parties, then no technology is going to solve the issue. And so I would say trust is really key. And sometimes we have to really invest in those areas to then speed up all of the process of data sharing and the artificial intelligence. And that's one of the key areas in AI as well. A lot of investments are going towards explainable AI, private model training. All of these technologies are not done just to improve performance, but also to ensure that privacy is in place and doctors can trust the whole process related with artificial intelligence.
ACM ByteCast is available on Apple Podcasts, Google Podcast, Podbean, Spotify, Stitcher, and TuneIn. If you're enjoying this episode, please subscribe and leave us a review on your favorite platform. Yeah, no, that sounds like the absolute right place to begin as well. And it's a little bit of I guess, a chicken and egg problem, right? I mean, if you show solutions that work, you show solutions that protect privacy and are yet effective in helping doctors do their job better. Similarly, see if patients that see better outcomes, there's probably a continued amount of trust that gets built. Have you seen anything specific done, or by specific, I'm trying to understand who are the sort of responsible parties who can really make an impact here? Would it be researchers and practitioners in the computing field? Or would it be like, say, evangelists, like doctors who we are able to sort of talk with and help them see the benefits of this technology, and then them being sort of evangelists for this in their communities? How do you see this sort of getting better?
I would say both parties. So the clinical community, which are the domain knowledge experts, and the technical community, so the ones that develop the tools. And that's why probably also there's been a bit of slowness, a bit of an issue so far, is that these two communities, clinicians basically, and let's say data scientists, speak two different languages and have two different sets of priorities. Doctors obviously want to focus on people, the qualitative aspects, on patients' health as it should be, and data scientists are focused on technicalities and model performance and so on. And so I would say over the years there has been progress that has been made, in trying to understand the two different sides of the same coin. Something like AI in healthcare, data science in healthcare is not just technicalities; it's about people, and vice versa. It's not just about patients' outcomes and their health, but also acquiring the data and using that data. And so on the technical side, it's key to invest and implement new technologies that leverage some of the explainability techniques and some of the also bias and fairness methodologies. So we want to focus on technologies which are more about how can we make models simpler, so to say, more understandable, more explainable, so that we can show them to doctors and explain to them how they're working. So going away to some extent from black box technologies to gain the trust of the doctors. And at the same time, on the doctor side and on the clinician side, there's an important aspect of having to sort of understand the value of some of these technologies, some of these models that are not going to be there to replace their job or perform diagnosis without the doctor's oversight, but actually to understand that these are tools that are going to be enhancing their work, and ideally also going to be taking over some of the administrative tasks, some of the burdens of the healthcare community. So it's a sort of dialogue between these two parties, and each one of them has to do some work to improve in their respective area and get to some sort of common ground.
Yeah, no, absolutely. I think you hit the nail on the head. It's that dialogue, it's that bringing together of those communities, each of them experts in their own areas, and trying to see where the intersection happens. I do have to ask, Eugenio, I know you've spoken about this as well in the past. In the absence of, say, real data, right, or scenarios that we haven't seen before, there is a concept of using synthetic data, and I know you've spoken about this in the past as well. What is your opinion on, I mean, one, if you could explain what synthetic data means, and what do you think of it? Do you think it's useful? Do you think it could be useful in some situations?
So synthetic data is data that is generated artificially through algorithms, through methodologies, not acquired through real life scenarios, through real people. And so I'm not personally a huge fan of synthetic data. I know that there are new technologies now that can create synthetic data even better than it's ever been done. But I'm not a huge fan because usually synthetic data is something that is generated through algorithms by data scientists, not acquired in real life scenarios. And so what happens here is that you usually have a very small amount of data, which is usually what's captured through real life scenarios. And then it's expanded through synthetic data technologies. So you start with a small amount of data and you try to expand it and generate more samples so that you can then have a bigger data set, a bigger population. And obviously, I would say everyone can understand that if you have a very small population, if you've got a very small subset of what's the total population, an algorithm cannot really understand all of the possibilities of a data set. And this becomes extremely challenging. If you think about, let's say, a patient population, we're going to capture a very small percentage of a population. This might not capture the whole broad aspect of possible diseases, possible procedures, but even more so all of the possible demographics, so to say. We might be focusing on only people that have a higher net worth than the average. And we might be, because of data acquisition limitations, not be focusing on people that are from lower income backgrounds. And so synthetic data sometimes tends to perpetrate and continue some of the discriminations and some of the bias that we can see in the real life scenarios, and expands it even further because it then creates even more data. So I think it's obviously a great technology. It tends to be, though, a great technology, in my opinion, for theoretical situations, maybe a bit more on the research side. And then in real life scenarios, it becomes relatively challenging, and especially on the bias and fairness side.
Yeah, no, I see the point that you're making. The inherent biases that we have in our data collection will only be exacerbated when you use it to generate more data. The last point that you made around it maybe being used more in the research side than in sort of the applied side. I'm wondering, though, the data that's used in the research side is what is sort of in general generating these models for us, right? So is there a risk to using it there? Also, are there certain fields or domains that might be more accepting of synthetic data, or it could not be as maybe harmful? I mean, bias in data is, I think, harmful no matter where, but I was just curious as to the now proliferation of synthetic data and like what people find beneficial in it.
Yeah, there are definitely risks. And I would say this also ties back to what we were saying before. Like, there might have been in the past some applications that were not so impactful on the people, on the outcomes. You can think of, I don't know, video apps where if you recommend a specific video to a person, well, if video is not exactly the correct one, doesn't really matter. I can scroll past that. And so you can think of social media applications and anything like that. So I would say that maybe in the past could have been a good example of an application where synthetic data and all of these applications might have been less impactful if wrong. If we look into false positives and false negatives, would have not been too big of a deal having used maybe synthetic data incorrectly or some of the algorithms. But I'd say now there is not really an application that I can think of that is not going to have a pretty important impact on the user population. And even if we think now about social media, as we said, it's something that now can really have huge impacts on a lot of big decisions all over the world. So I would say synthetic data still remains, in my opinion, something that has to be really considered and really go through a thorough process of bias evaluation, fairness evaluation before being used. Obviously, it's a great technology. It's just that it's something that has to be vetted and not just used blindly. I would say sometimes that's what happens in the technical areas. Sometimes you might have technical experts that might be experts on the algorithms that create this synthetic data, but they might be lacking the domain knowledge, the domain expertise of, let's say, a doctor that knows that synthetic data might not be a great representation of our population. It might be missing someone. In terms of ethnicity, income, and all different other demographics. And so they would know that could lead to outsized negative impacts.
Yeah, no, that's a very, very relevant and an example that really sort of hits the point home. Thank you for sharing that. So to change gears a little bit, Eugenio, I know you've obviously as a student, as a researcher, you've been in sort of smaller academic type of settings where you have the luxury of sort of moving fast and going from, say, ideation to implementation with very limited friction, and then from there on, you're now working for a Fortune 5 company. And while you're still in, I guess, in your capacity as leading research, how have you had to change your sort of working style and expectations? Sort of what's your philosophy as, working as I guess, as an entrepreneur now?
Well, that's a great question because I definitely have to say that throughout all of these different experiences, one commonality, one of the things that you learn is that you always have to adapt your skills and your attitude to the situation. And even though I might be doing data science and AI in all of these different areas, so from academia to a big corporation to startups, there's still a lot of different aspects that change a lot of the day-to-day. And so one of the areas that changed a lot, going from academia, from research, and being a student or a grad student to working for a big company, is definitely the level of understanding of the stakeholder environment. So obviously the academic environment is much more about the technical components. How can we push the state of the art as much as we can, and how can we develop tools and technologies that might not be immediately helpful, they might not be immediately answering a question, but we have this belief and hope that they will at some point. So it's much more about how can we develop the better tools and technologies with the most state-of-the-art technologies. Well, working for a big corporation, especially with a big company, it's actually quite the opposites. How can we dumb things down to something that can be actually put into production? It's not about trying to build the most complex and innovative solution. It's rather about how can we find the needs and the priorities of all of our stakeholders and try to understand how we can really make the simplest solution that can answer those questions. Because of the fact that the more complex the solution, the more difficult it is to implement it, to manage it, to implement it in production, and also to maintain it. over time, taking into account all of the different other issues of ethics, bias, and so on. And so definitely a lot of differences, and much more on the people side and much more on the trying to make things simpler, maybe linear regression or logistic regression rather than deep learning, to try and get things done that can help the stakeholders and all the users.
Yeah, and I think that point can't be sort of emphasized enough, because I feel like even as, I mean, I come from an engineering background, but even as engineers, you oftentimes want to build something that's exciting. You want to, because that's what you do, you build things, right? But I think keeping in mind who are your users, how do you keep this most simple? Not just so, your end user is one thing, but all of the various functions that you interact with in a large corporation, and trying to sort of take them along on that journey of adoption of the solution, I think is so critical for the success of any solution.
Yeah, and that's also one of the biggest issues and challenges I see, especially on the more junior data scientists. Like, we're also passionate about building models, do hyperparameters tuning, and play with machine learning and some of the latest technologies. Could be ChatGPT, could be anything else. But sometimes we have to really stop ourselves from going down those paths and stop to understand some of the requirements and some of the needs, and actually push ourselves towards doing simpler solutions rather than the more complex ones. So with more seniority also comes a lot of an understanding that sometimes we really have to stop ourselves from going maybe the deep learning route and stop at the linear regression, logistic regression side, because that's enough, gets the job done, and then we can iterate later on.
Got it. Yeah. And though I have to ask Eugenio, because this is a question that I often get asked as well, is from moving from being sort of hands-on researcher and data scientist, I don't know how much of your time today is spent on those activities, to, managing and leading teams. How do you find a sense of accomplishment? I mean, oftentimes when you're building something yourself, you can see the outcome of your efforts, versus in situations like when you're leading a team, the collective result of the team's work is what you have to show. So have you thought about that? Has that something that's crossed your mind at all?
Yeah, it definitely has. And it's one of those things, as we said before, that change a lot. Like, in the same way that going from academia to a big company, you have to adapt a lot. In the same way, if you go from an individual contributor to a people manager, things change a lot. And I would say right now, success to me is more about seeing in other people, in other members, in other people in my team, success on themselves. So seeing actually the developments that they do and see how they can achieve the requests, the requirements, and put things into production effectively. That's, to some extent, indirectly, I feel it's also a success to some extent on my part. And I really value a lot when communication flows effectively and when people work seamlessly to some extent. So I'd say that's now a bit more of the definition of success to me, or at least what makes me feel that, yes, something has been done actually well, compared to when before it was more about performance metrics of a model.
I love that easy flow of communication. Do you have an effective way of measuring that? Because I think that that is super crucial. And I think that that would be a great sense of accomplishment for anybody who's leading a team.
Yeah, it's a difficult one. I would say the number of miscommunications, so to say, so the number of times that at least I was expecting something and that actually came across like that. And also with stakeholders, the number of times that they request something on time, and actually the solution answers their question. That's one of the challenges of going from technicalities and being an individual contributor to a people manager. That's all much more qualitative rather than quantitative. And so it's one of the big challenges, especially for a data scientist, trying to navigate success in a very qualitative world of people management and stakeholder management.
For sure. Yeah. No, thank you. That's a great way of looking at it. With all these problems that we're trying to solve using data, Eugenio, there is a burgeoning sort of need for data scientists, right? I see a lot of colleges and universities that are offering a data science program now, in addition to, say, a computer science or a computer engineering program in undergraduate education. What are your thoughts on some of these programs, how they are structured, and how can one make the most use of it if somebody is trying to get into the field?
So first of all, I'm a big proponent of just communication and education in data science and AI broadly. So regardless of university-based courses, even just free courses, I'm a big proponent of trying to share the knowledge of these topics as much as possible. One of the caveats, though, that I see oftentimes is that people that only rely on technical courses miss probably the most important lessons there. So they miss the importance of understanding the requirements, from a stakeholder, understanding the needs of a user, of a person. And so I wish that universities and also just free open source courses focused more on real life applications, so to say, of data science, and how much it's not just about developing a model or working on feature engineering, but it's actually a lot about trying to better understand the needs of a client, of a stakeholder, and translating that into something that can get the job done. And at the same time, also the bias and ethics applications of data science. I feel that a lot of times data scientists are trained on the algorithms, on the technicalities, but not on the possible real life implications of what they do. And so oftentimes there's a bit of a disconnect with the domain knowledge experts. So there's often a disconnect between clinicians maybe and data scientists. And so having more courses or more focus on all of the real life applications or real life domain applications, I feel would help a lot in going forward also the career and the experience of a data scientist.
Yeah, no, that's excellent advice. In the absence of the courses being sort of modified to include more real life applications, do you have any suggestions for students on how could they, in their own time, pursue a better sort of understanding of, customer challenges or user challenges and build solutions that are effective?
It's a difficult one, but I would say to try and work on side projects that come not from technical experts, maybe professors on technical topics, but rather side projects that come from domain knowledge experts. So it might be asking the local doctor for ways that they can help them through data science, through technology, improve some of their needs. I think that in this way you can understand a lot of the cultural components, a lot of the real needs of domain experts. And this is a fantastic lesson for data scientists, that it's not just about the technicalities, it's not just about the algorithms and the data, so to say. It's actually about the real life problems and everything that's around the world of AI and data science.
That's such pertinent advice, Eugenio. Thank you for sharing that. It's a very, very great nugget of information for our listeners who want to sort of break into the field of data science, especially in the healthcare domain. So for our final bite, I'd love to hear from you sort of what are the large problems that you're trying to solve as a part of your current role or, in general in the field of healthcare and AI, what are you most excited about over the next few years?
So I'm definitely excited about the ability to use AI and machine learning to try and predict and so prevent diseases. I feel that AI and data science now has the ability to shift the concept of medicine and healthcare from something which is more about curing and a more reactive approach to something which is about preventing diseases before they even happen. So I think that's going to be completely shifting how we live life and how we approach also going to a doctor. It's going to be more about prevention rather than curing something. And I'm also particularly interested in everything that's about personalization. So trying to use, again, machine learning and all of these technologies to try and understand what's the best way to have positive impacts and positive outcomes on a person thanks to all of the past data that we have. So given all of these analysis and all of these models, we can better understand what could be the best ways to intervene on a specific person. And the third and probably the single most interesting thing right now, not just for healthcare, but in general, is how we can use all of these technologies like ChatGPT and large language models in the healthcare sector, taking into account the possible issues with obviously having such powerful models dealing with such challenging sector, but also all of the possible ways we can use, for instance, ChatGPT or large language models to release a lot of the burden on the administrative tasks on doctors. So I see, for instance, very soon ChatGPT being able to deal with a lot of the admin tasks from doctors. So when they enter information on a patient and things like that, to allow the doctor to focus more on the health of the patient. So definitely a lot more to come in that area.
Yeah, I love the vision that you're painting, Eugenio, both in the healthcare industry and across. This has been really very fascinating. I've enjoyed conversing with you. Thank you so much for taking the time to speak with us at ACM ByteCast.
Thank you for having me. It's been a pleasure.
ACM ByteCast is a production of the Association for Computing Machinery's Practitioners Board. To learn more about ACM and its activities, visit acm.org. For more information about this and other episodes, please visit our website at learning.acm.org/bytecast. That's learning.acm.org/bytecast.